All right, guys, here we go on page 38. Looking at same kind of process, but here we're going to be looking at polyatomic ions. So Lewis structures for polyatomic ions. Again, we follow the exact same steps as we have been before, except we're also going to use square brackets and the charge of that polyatomic ion. Okay, let's take a look at our example. NH4 with a +1 charge. So again, do your total like you normally do. Nitrogen equals 1 times 5. That gives us 5 valence electrons. Hydrogen equals 4 times 1, and that's going to give us 4. And then that gives us 9 valence electrons. Now, based on all of the other examples that we've done for Lewis structures, that 9 should look suspicious. All of the other ones had even totals of valence electrons. And that's actually a very important thing to take away from this. Remember that pairing electrons is very important when it comes down to bonding. So if I get an odd number, something's up. Okay, and what's up is that there is a +1 charge indicated. This structure, this polyatomic ion, its name is ammonium. Okay, you need to remember that. NH4 with a +1 charge is ammonium. Okay, so then what does that do to our total? Well, like we've learned before, a +1 charge really tells us that we should do what with the electrons? Plus means to subtract electrons. So we're actually going to take 1 away right off the top. And that's going to give us our actual value of 8 valence electrons. Okay, and then from there, it's just the same as normal, okay? So we're going to put our central atom in the middle, surrounded by as many hydrogens as it says 4. Okay, but since this is a charged particle or a polyatomic ion, I'm going to indicate that by putting my square brackets, just like we did when we're doing ionic bonding, okay? So when I subtract out my bonded electrons, 2, 4, 6, 8, that uses up all 8 valence electrons right away, and that structure is done, okay? Again, the thing to take away from here is that the plus charge tells you to subtract electrons, and that's going to fix your odd number to be an even number. And then when we draw the structure, we add square brackets and the charge. Okay, let's take a look at another one. Our second example, or actually this is a practice problem. This is practice number 11. And the formula for this is ICl4 with a -1 charge. So again, we start it the same way. I equals 1 times 7. That gives us 7. And then Cl is 4 times 7, which gives us 28. When I add those two together, I'm actually going to get 35. Whoops. 35. Okay, so 35 is an odd number. That should be very suspicious to you. And the reason that that looks weird is because we haven't yet accounted for the -1 charge. So the -1 tells me that we actually need 1 more electron. So in actuality, we have 36 valence electrons. All right, so then this brings up another interesting idea. Previous to this lesson, we've always said that I, Cl, F, and Br never go in the middle because they only bond once. Well, this is going to be an exception to that. Iodine, because there's only one of them, is the one that's going to go in the middle. Okay, and if you'll remember from a couple lessons ago, the reason why iodine can go in the middle, let you jog your memory real quick while I find my periodic table. The reason that iodine can go in the middle is because look at where it is. It's in the 5p orbital. So what does that mean it has before it? It's got a d orbital. And remember, all of these guys over here that have a possibility for expanded octets. Okay, anyway, since there's a charge indicated on the formula, I automatically know I need to put square brackets around the structure. Structure's not finished yet though, because I still have all these electrons to account for. So from the total, I need to subtract out the bonds, 2, 4, 6, 8. When I take out 8, we have 28 left over. Okay, so 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, and 4. Okay, when I take away those 24, that's going to leave me with 4 extra electrons. And again, thinking back to a couple lessons ago, where are you supposed to put any additional electrons? They go to the central atom. Okay, and don't forget to circle them. That tells me that those electron clouds are taking up space. All right, try those next 2 on your own. And like I said before, if you ever have any problems, please call me over so that I can help you.